The Arabian Peninsula, long synonymous with oil, endless stretches of sand and a harsh, arid climate, has just upended global science with a groundbreaking discovery emerging from the heart of Riyadh. On September 20, 2025, the Saudi Geological Survey, in collaboration with King Abdullah University of Science and Technology, announced a finding that challenges the very foundations of modern geology and earth science. This time, the news isn't about oil or energy resources, it's about something even more essential: water. Saudi Arabia has uncovered a massive, previously unknown subterranean body of fresh water hidden deep beneath the Rub al-Khali, also known as the Empty Quarter, one of the most inhospitable deserts on Earth. The initial press conference, which many expected to focus on mineral resources, took a dramatic turn as Dr. Fatima al-Rashid revealed seismic data and geological evidence that left the scientific community in awe. This isn't a typical aquifer or a known fossil water reserve that's been mapped before. The data points to something much deeper, far larger, and geologically inexplicable, an anomaly that defies current scientific understanding. The discovery directly challenges long-held models of Earth's water cycles and crustal structure, especially those developed and taught in the West for generations. For decades, scientists believed water distribution and rock porosity at great depths were well understood. This find suggests that our knowledge may have been incomplete, or even fundamentally flawed. The implications are staggering, touching on water security for arid regions, the global conversation on climate change, and even our theories about how planets, including Earth, form and evolve. International reaction has ranged from excitement and hope to deep skepticism, and calls for further investigation. U.S. scientists and research institutions are urgently seeking access to the full dataset for independent verification, eager to understand the true nature of this discovery. This announcement opens a new frontier in Earth science, forcing experts and students alike to rethink what lies beneath our feet and what secrets the planet may still hold. The sands of Arabia, it turns out, have been hiding a secret more valuable than oil, a resource that could reshape the future of the region and the world. The world is watching closely as a new and unexpected chapter in geology begins, with the potential to change our understanding of Earth forever. Deep beneath the endless sands of the Rub al-Khali, also known as the Empty Quarter, lies a mystery that has stunned the scientific community. The Rub al-Khali subterranean anomaly is located approximately 250 kilometers southeast of the Sheba oil field, in one of the most remote and inhospitable regions on Earth. This anomaly was first detected almost by accident during a deep Earth mineral survey that utilized next-generation seismic imaging technology. The survey, intended to map mineral deposits, instead revealed something far more extraordinary. The Saudi geological team, while searching for rare earth metals vital for modern electronics, stumbled upon a massive, low-density, non-viscous body buried 15 to 30 kilometers below the desert surface, far deeper than most known aquifers or mineral deposits. This enigmatic structure lies beneath the ancient Arabian Shield, a region long believed to be solid, impermeable bedrock, untouched for millions of years by significant geological change. At first, the seismic readings were so unexpected that many experts suspected equipment malfunction or data errors. However, after 18 months of rigorous, repeated scans and independent verification, the anomaly's existence was confirmed beyond doubt. The scale of the anomaly is staggering. Early estimates suggest it spans an area of 60,000 square kilometers, with a thickness ranging from 5 to 15 kilometers. To put that in perspective, it's larger than many countries. If filled with water, this underground reservoir could potentially hold more than all the surface freshwater lakes on Earth combined, making it one of the largest known subterranean features on the planet. Unlike a simple underground lake, the anomaly appears to be a labyrinthine network of vast, interconnected caverns and chambers, a true subterranean ocean, hidden from the world above. What makes this discovery even more perplexing is the Rub al-Khali's remarkable tectonic stability. This region has experienced little geological upheaval for millions of years, making the formation of such a vast void even more mysterious. Scientists are now grappling with fundamental questions. How could such an immense space form in a geologically quiet region? What processes could have created and filled it? The global scientific community is captivated, and speculation runs wild. The Rub al-Khali anomaly challenges our understanding of Earth's deep interior, raising more questions than answers. As research continues, it promises to redefine what we know about the hidden world beneath our feet. The true shock isn't just the size of the anomaly but its composition. Advanced seismic analysis shows the liquid is fresh water with salinity less than 500 parts per million. This defies geological logic. Water at such depths should be briny, not pure. High pressure and temperature should dissolve minerals, making deep water saline, yet this reservoir is remarkably fresh. The source is a mystery. It sits far below any known aquifer and appears isolated from the global water cycle. The leading theory is that this water is primordial, trapped since the Arabian Plate's formation billions of years ago. If true, similar reservoirs could exist beneath other stable continental plates. This discovery expands our planet's water budget and challenges the very definition of an aquifer. We may be looking at a new category of water resource, one we never imagined. The Saudi claim is built upon a foundation of detailed isotopic analysis, a method that allows scientists to peer into the hidden history of water deep beneath the Earth's surface. Without access to direct water samples, the research team had to get creative. They inferred the water's unique chemical signature by carefully studying the hydrogen and oxygen isotopes locked within the surrounding rocks, which act as natural record keepers of ancient water. The results were striking. A uniquely low deuterium to hydrogen ratio, a chemical fingerprint that stands apart from any known surface water on Earth, suggesting something extraordinary. This evidence points strongly to a primordial origin, indicating the water has been isolated from the surface hydrological cycle for millions, perhaps even billions of years. If these findings are confirmed, they could offer scientists a rare and invaluable glimpse into Earth's early history, revealing secrets about our planet's formation and evolution. The volume estimates are nothing short of staggering. Conservative scientific models suggest there could be as much as 2.2 million cubic kilometers of water hidden below. To put that in perspective, this underground reservoir could hold nearly 100 times the volume of all of North America's Great Lakes combined, making it a truly colossal discovery. The sheer scale of these numbers has led many hydrologists and geologists to remain skeptical, questioning whether such a vast reservoir could really exist. Critics point out that seismic data can sometimes be ambiguous or misleading, but the Saudi team has responded by using a multi-method approach, combining seismic, gravimetric, and magnetic data to strengthen their case. All three independent methods, seismic, gravimetric, and magnetic, consistently point to the presence of a massive body of low-density liquid, which is most likely water. The global scientific community is watching closely and demanding even more proof, but with each new piece of evidence, the case for this discovery grows stronger. If ultimately verified, this would stand as one of the largest and most significant water discoveries in human history, potentially rewriting what we know about Earth's hidden resources. The U.S. scientific community is both astonished and skeptical. Leading geophysicists at MIT, Stanford, and the USGS are re-examining their models in light of the Saudi data. The prevailing belief, at such depths, porosity vanishes and water should be locked in minerals, not free-flowing. The Saudi find contradicts this, especially given the water's unexpected freshness. American models insist deep water must be briny after eons of contact with hot rock. The idea of a primordial freshwater ocean preserved for billions of years is unprecedented. U.S. researchers are now scrambling to develop new theories and re-examine old seismic data worldwide. The discovery exposes a blind spot in Western science, shaped by limited regional studies. The unique geology of the Arabian Plate may hold the key, and Saudi scientists are now seen as pioneers in this emerging field. The world's hydrological textbooks may need a rewrite. The Rub al-Khali anomaly forces a rethink of plate tectonics and mantle processes. The Arabian Plate, a relatively young continental crust, now appears to harbor a deep freshwater ocean. Some scientists propose this water could act as a lubricant, altering the plate's movement and stress patterns. Water lowers rock's melting point and could make the lower crust more dynamic than previously thought. The discovery suggests continental plates may store vast amounts of primordial water, bypassing the mantle's subduction cycle. If true, other stable cratons like those in North America or Australia could hide similar reservoirs. This possibility could rewrite planetary geology and our understanding of the global water cycle. The crust may be far more complex, with hidden liquid layers influencing Earth's evolution. The anomaly is a call to re-examine the deep Earth as a dynamic, multi-layered system. This discovery was made possible by Saudi Arabia's Deep Earth Sonar Array, or DESA. DESA uses hundreds of advanced seismic vibrator trucks and thousands of geophones, linked by a fiber optic grid and satellite radar. This network creates real-time, high-resolution 3D maps of the deep crust reaching depths previously unimaginable. The data is processed by a dedicated supercomputer at KAUST using AI-enhanced algorithms to filter noise and reveal subtle density changes. This technological leap marks a shift in global scientific leadership. For decades, the West led in geophysical imaging. Now, Saudi Arabia is at the forefront. The DISA system's success signals a new era of discovery, with advanced tools no longer confined to a few nations. The world's scientific map is being redrawn. Policymakers are asking, can this water be accessed? If so, it could transform the Middle East, ending reliance on desalination and reshaping global water security. But the technical challenges are immense. Drilling 15 kilometers down is beyond current technology. For now, the anomaly is a scientific marvel, not a practical resource. The discovery also impacts climate science. Current models don't account for deep crustal water bodies. If there's any interaction with the surface, it could alter our understanding of heat flow and climate trends. The anomaly also offers a new context for studying life in extreme environments, with implications for astrobiology. This hidden ocean could become a laboratory for exploring the limits of life on Earth and beyond. Saudi Arabia's announcement has opened a new era in Earth exploration. The Rub al-Khali anomaly reminds us how little we know about our own planet's depths. We've mapped Mars better than Earth's deep crust. This discovery forces us to look downward with renewed curiosity. A vast freshwater ocean hidden beneath a desert challenges everything we thought we knew. The implications span geology, hydrology, climate science, and the search for life. As scientists race to verify and understand this find, one question lingers. If an ocean can hide beneath a desert, what else lies waiting deep within the Earth? The journey to answer that has only just begun.